All right, so we're doing number 70, but it says we have to use number 69. So this is what we're doing. So it says a small plant manufacturing lawnmowers is what we're looking at here, and the plant has fixed costs, which are leases, insurance, etc. Well, in this case, it looks like our cost is 65,000 when we do this one, and the variable cost of $1,400 per unit. But now with the new equation, we have $1,100 per unit. And then it says the mowers are sold at $1,800 each. Well, and now the new one, we're selling them for $1,600 each. Okay, so that's our cost equation and our revenue equation. And X is going to be the total number of mowers that are produced and sold each day, and the daily cost and revenue are all in dollars. Now, we're supposed to find out how many units must be manufactured and sold each day for the company to break even, and then graph both equations in the same coordinate system and show the break-even point, and interpret the regions between the lines to the left and to the right of the break-even point. All right, so basically what we need to do is kind of show what it is. So this is, now if we're doing these, a lot of times we'll say this is actually C of X, and this is going to be our R of X. So instead of Y, we'll say C of X and R of X. But because we're going to type it into our calculator, we'll go ahead and leave it like that. So let's go back to our calculator. Now we need to clear all these out. And our first equation, they said now we have 65,000, and then that was times, or actually plus 1100x. And our other equation was 1600x. And now we have to think about our window. So our window is going to be, let's go from, I don't know, we probably only have positive since we're making things. So we could start at really zero here. And max, I don't know, let's go up to 250. I don't know what we're needing here by 50. And our Y value, again, hopefully we're only making positive numbers. If we have 65,000, maybe let's go to 150,000. And let's go by 50,000 and see where we are, because I don't know where we're going to be. All right, so we're not quite high enough. So down here, so instead of doing that, let's go to 300,000 and see if we're close enough there. All right. So this is going to be our break-even point when our cost and our revenues are basically the same. And that's going to be at that point is. And so now what we have to do is we actually have to find out what point that is as far as X and Y for that matter too. So we'll do second trace 5, and we'll just enter first curve, enter second curve in our guess. And it says that we have to sell 130 mowers and we're going to make $208,000. Okay. So I think they also asked for something else here. What was the other thing? Graph both and interpret the regions between the lines to the left and to the right. Okay, so interpret the regions to the line to the left. All right, so to the left and to the right. So over here, basically, the cost is higher than the revenue because this is their revenue, this is their cost. So here, the cost is higher. But over here, the revenue is higher than the cost. So that's why at this point where they're equal, that's the break-even point. So cost is higher, revenue is higher. So that's kind of what we're looking at here. So now let's go back over here. And so part A is asking for how many units must be manufactured. So X has to be 130 mowers. And then our C of X, our cost, is equal to our R of X, which is our revenue. And that was equal to, we said, $208,000. And so for B, to the left of this break-even point, the cost was higher. And to the right, the revenue was higher. Okay. All right. So that's going to be how you would do something like that one. You'd have to kind of graph it and then go from there and kind of see what you get. So hopefully that helps on that one. Let's come back for another one.